Here in this video, we are solving a NEET 2025 question from the chapter Electromagnetism. The question is like this. An electron of mass given for you, charge, though these are the standard values, they are given for a reference in the problem. Moving with a speed of c by 100. So, velocity of an electron is given for you as c by 100, where c is the velocity of light, who is fixed 3 into 10 power 8 meter per second by 100. So, velocity is 3 into 10 power 6 meter per second. With this velocity, an electron is moving. It is injected into a magnetic field of 9 into 10 power minus 4 Tesla. It is given that it is subjected to a magnetic field of 9 into 10 power minus 4 Tesla perpendicular to its direction of motion. It is moving perpendicular to the direction of the motion. The specific direction of the electron's magnetic field is not given for us, but we can understand now further. We wish to apply a uniform magnetic field together with a electric field together with a magnetic field, so that electron doesn't deflect its path. Then find the value of that electric field is the question. Yeah, let's try to understand what is given for you. This is an electron moving. This kind of a setup can be experienced or you might have studied in J.J. Thomson experiment. So, we will apply in J.J. Thomson experiment, or in this case an electric field with the help of a battery. This is the positive plate of the battery, or you can say negative plate of the battery. This is the positive plate of the battery. So, electron being having a negative charge, who is supposed to go undeviated when there is no electric field, now attracted towards the positive plate of the battery. So, it is not, after entering into this electric field, it deflects towards the positive plate of the positive charge available. That is the positive plate of the battery. It has gone like this because it is experiencing a force due to the electric field. How much is that? Is called EQ. Now, he is saying, I need to apply a magnetic field in such a way that electron doesn't deflect. In that case, we have to apply a magnetic field perpendicular to the electric field. Again, I can apply magnetic field in such a way that this is into the paper or into the page, like I am drawing the cross, it is into the paper. So, what is that? So, if you apply magnetic field like this, it will experience a force due to the magnetic field. A charged particle will experience a force due to the magnetic field. Force due to the magnetic field is BQV sin theta, but it is entering into the magnetic field perpendicularly. BQV sin 90, that is equal to BQV itself. To know the direction of this, we shall apply Fleming left hand rule. Fleming left hand rule, which says that if your forefinger indicates a direction of field, that is magnetic field, forefinger direction of magnetic field. Now, I want you to stretch your 3 fingers of the left hand perpendicular to each other. Put your forefinger into the page, into this video page, into this cross mark. So, your forefinger is going into the page. Look at your central finger. This central finger shall be along the direction of current. Central finger along the direction of current. Forefinger field B. Central finger C, current C. But here what we have taken is an electron. Direction of the current is opposite to the motion of an electron. So, you turn your hand, left hand, after stretching your 3 hands perpendicular to each other in such a way that your forefinger is like this going into the page, and your central finger is against the direction of an electron. That means it has to be like this, in this direction, central finger. And then where is the thumb is? You can see in the perpendicular plane, it is downward. So the thumb gives the direction of thrust or force. So how is the direction of the thumb? Hope you are able to do it by putting your forefinger into the field, that is into the page like this. Central finger opposite to that of an electron, that is from right towards the left. It's obvious that your thumb now moves downward, appears in downward. So what's the direction of that thumb that you can experience is this way. That means in this direction it will experience a magnetic field F is equal to BQV due to the magnetic field. It is very clear by looking at this that these two forces are acting in opposite direction on the same charged particle. So if force due to the electric field is equal to the magnitude of force due to the magnetic field, they do cancel each other and electron goes undeflected in the magnetic field. So EQ equal to BQV, electron Q is gets cancelled. You need to calculate electric field E, so its value shall be BV. That's the answer for your problem, where B is the magnetic field, right? B is the magnetic field. What is the magnetic field value given for you? 9 into 10 power minus 4 Tesla. V is C by 100, that is this much. 3 into 10 power 6, that is 27 into 10 power 2. Electric field has a unit of volt per meter, right? That's how we have to find out. So its value has to be 27 into 10 power 2, right? So but 27 into 10 power 2 is there in both places, right? But look at the fourth option, E is parallel to B. If E is parallel to B, these two forces cannot act in opposite directions. So this is definitely wrong. These numbers are wrong. Look at this. E is perpendicular to B. This is perfectly alright. E in this case is in the plane like this. B is perpendicular to the plane into the paper. This is how we have to solve the problem. So this is the value of electric field. E is perpendicular to B, right? So option 3 is the right answer for this problem. Thank you for listening.